Hi, and welcome to another installment of Math Basics, Mr. Besh. Today we talk about four-sided figures, also known as the quadrilateral. We will define their components, and I will also teach you how to calculate both the perimeter as well as the area. Let's take a closer look at our family. The quadrilateral, there are five: square, rectangle, rhombus, a parallelogram, and a trapezoid. Now, because a trapezoid has two different looks, I'm going to break each of these shapes down as if they were different, even though they're calculated exactly the same way. Now, things I want you to know about quadrilaterals. First, all quadrilaterals have four sides. And secondly, all quadrilaterals have four angles inside. These four angles add up to be 360 degrees. This is a property that they all share. Now, my first of my shapes in my family is the square. What I know about a square is this. A square has four sides and they're all congruent, meaning they have the same value. So in my model, if one side is 7 centimeters, they're all 7 centimeters. The second thing I know about a square is if I were to, add up all four angles inside there, I know it adds up to be 360 degrees. But each of the angles have exactly the same value. So now, as a result, because the angles have the same value, they would all be 90 degrees inside. Also notice that the left and right sides are perpendicular with the top and the bottom. When I go through my calculations to find the perimeter of a square, you basically add up the four sides. Well, if you know one, you know all of them. So 7 plus 7 plus 7 plus 7 is going to give me 28 centimeters. I could have simply just taken 4 times 7 as well. To calculate its area, notice the formula on the right-hand side. A equals S times S. Sometimes they refer, and you'll see this in a bunch of different texts, they'll refer to this as being the sides, standing for S. Sometimes you see the length times the width. Other times you might see the base times the height. Either way, it is represented by the same value. When you multiply a side times a side of a square, you're multiplying the same number by itself. In my example here, the base and the height, the length and the width, or sides are all going to be the same, 7 centimeters. So my area is 7 times 7, which is 49 centimeters squared. Please pay attention to also the unit of area. Every time you calculate an area, you got to make sure you put it into units squared or square units. The second shape in my family is the rectangle. The rectangle has similar properties of that of a square. Four sides, obviously, all quadrilaterals do. The four angles inside are all 90 degrees apiece. But unlike a square, the left and right side are not the same as the top and the bottom. On a rectangle, the left side being 4 centimeters means that the right side is also 4 centimeters. And that the bottom, 9 centimeters, also tells you that the top has to be 9 centimeters. On a rectangle, parallel sides have the same exact value. Now, when I go and I calculate its perimeter and area, it's done exactly like a square. The perimeter is found by taking all the sides and adding them up. 4 plus 9 plus 4 plus 9. If you notice in the upper right-hand corner, there's two formulas, one for perimeter, one for area. The perimeter formula says P equals 2L, which means 2 times the length, plus 2W, which means 2 times the width. Well, the width is going to be 4 centimeters in this picture. The length is going to be 9 centimeters. Notice that I also calculated that for you below. 2 times n plus 2 times 4. Either way, using the orders of operations, I get the exact same answer, which is 26 centimeters as my perimeter. Now, the area is found by taking, again, the length times the width. And now in my example, my length times my width is 9 times 4, which is going to give me 36 centimeters squared. Not much work involved in finding the perimeter and areas of both a square and a rectangle. Now, the third shape in my family is the rhombus. Okay? The rhombus has a similar property of a square. All four sides of a rhombus have the exact same value. The difference between this is if you notice the sides of a rhombus, they're slanted. Now, it's in perspective, however you want to look at it. I could take this rhombus and turn it on its side, then the top and the bottom are slanted. But what I know about a rhombus is that opposite sides basically are parallel. If you notice that also about all your quadrilaterals, except for that of the trapezoid, opposite sides are parallel of each of these shapes. When I go and I calculate the perimeter and area of the rhombus, the perimeter again is simple. If I know one of the sides is 6, they're all 6. So 6 plus 6 plus 6 plus 6, or simply 6 times 4, which gives me 24 centimeters. The key here is finding the area. A lot of mistakes are made with a rhombus or parallelogram, and the reason for this is the height. The height cannot be a diagonal or slanted line. The height has to be perpendicular with the base, meaning it has to form a 90-degree angle. Like in my example here, the height in my picture is 5 centimeters. The height is the distance from base to base. Now, it all depends upon your perspective of how you're looking at it, how your shape is, but remember, your height has to be perpendicular with your base. So now, my base being 6, my height, the distance between the two bases, the top and the bottom, comes out to be 5 centimeters. So now using the formula, A equals B times H, which means the area equals the base times the height, gives us 6 times 5, which is 30 centimeters squared. Now I'm going to piggyback on the rhombus to get to my fourth shape in the family, which is the parallelogram. The parallelogram, like the rhombus, has a similar look, except the parallelogram is more like the rectangle as the rhombus was more like the square. The parallelogram has similar properties to a rectangle. For instance, if the left side is 5 centimeters, that means the right side is 5 centimeters. If the bottom is 9 centimeters, that means the top has to be 9 centimeters. But then I would go about and calculate the area exactly the same way as I would do a rhombus. First, the perimeter, I basically add up all the sides. 5 plus 9 plus 5 plus 9 add up to be 28 centimeters. Now the area has to be the base times the height. And again, the base and the height have to be perpendicular with one another. I just can't take 9 times 5. Remember, the height can never be a slanted or diagonal line. And sometimes people look at it and say, well, wait a second, the height and base make a gigantic shaped L. Well, yes, they do. That's what it means when they're perpendicular. So now the area would be 9 times 4, which would come out to be 36 centimeters squared. Now, the last of my shapes is my trapezoid. And I told you I was going to break this down into 2 parts because they can have 2 different looks. The first look of a trapezoid is this. Both of my sides, left and right, are slanted, having exactly the same value. And notice that every trapezoid has 2 bases. The base of a trapezoid is identified as the 2 sides that are parallel to one another. In this example here, it is the top and the bottom. Now, to calculate this trapezoid's perimeter, I basically add up all the sides. So then I would take and go straight around. 8 plus 14 plus the bottom, which is 12, and the other side would be 14. That's what's neat about a trapezoid of this shape. If this ends up happening along the lines like this trapezoid here has that same exact value. Now, some things that I notice about this. Not all the time do the slanted sides on each of these have to be the same value. And that is a misconception by students from time to time. This example, they do because I'm telling you that ahead of time. Remember in math, you never want to assume. All right? When you're finding the perimeter of a shape, you need to know the exact value of each of the sides to add them up. I'm not just guessing that the other side is 14 feet. This is one where I know it's going to be 14 feet. So now when I'm doing my math and I break this thing down, 8 feet, 14 feet, 12 feet, 14 feet add up to be 48 feet. Now, when I calculate the area, the formula up in the right-hand corner says the area equals, now, h over 2 means the height divided by 2. Then next to it is, in parentheses, a plus b. This means I'm going to take the height divided by 2, and then I'm going to multiply that by the sum of the top and the bottom, according to my diagram, the A and the B. Those are basically both your bases, your first base and your second base. So now if you look at my formula, the height of this figure is 10. Notice the height works the same way as the rhombus in the parallelogram, which is 10 feet. So then I take 10, divide that by 2, which gives me 5. Using my orders of operations, remember the first step I would do is the 8 plus the 12, which would give me 20 inside that parenthesis. And then I would have to take 20 multiplied by the 10 divided by 2, which is 5. And 20 times 5 is going to give me 100 feet squared. Remember, it's area, feet squared. The second look of a trapezoid is along the lines like this, where the actual height is one of the side measurements. Now, this one's real easy always to calculate its perimeter because you always know exactly what the 4 sides are going to be. The bases are exactly the same. If I look at my model again, when I find my perimeter this time, it is going to be 6 plus 10 plus 12 plus 8. And when I add all those up, I get 36 feet. Now the area, remember the height of this figure is one of my sides. It's going to be 8 feet because that height now is perpendicular with my base, which is 12 feet or 6 feet. However way you want to look at it, they both form 90-degree angles. Also, the distance between the 2 bases is also my height. So now my area, when I calculate the formula, I take my 2, A plus B, or the base on the top, base on the bottom, add them together first, orders of operations. 6 plus 12 make 18. And then I multiply it by out front, the height divided by 2. The height is 8, divide that by 2 is 4, and 4 multiplied by 18 gives us 72 feet squared. This is our four-sided family, the quadrilaterals. I hope you find this helpful.